Myself Anamika Khuntela. I am a research scholar at University of Kota, Kota. My topic is cleavage. Definition of cleavage. Cleavage is a rapid series of mitotic division that occur just after fertilization. It is the first phase of embryonic development. There are two critical reasons why cleavage is so important. First, generation of a large number of cells that can undergo differentiation and gastrulation to form organs. Second, increase in the nucleus cytoplasmic ratio. Eggs need a lot of cytoplasm to support embryogenesis. It is difficult or impossible for one nucleus to support a huge cytoplasm, and oocytes are one of the largest cells that exist. One small nucleus just cannot transcribe enough RNA to meet the needs of the huge cytoplasm. Main differences between cleavage and mitosis. First, blastomere do not grow in size between successive cell divisions as they do in most cells. This leads to a rapid increase in the nucleus cytoplasmic ratio. Cells undergoing cleavage have mainly S and M phases of the cell cycle, little or no G1 or G2 phase. Cleavage occur very rapidly, and mitosis and cytokinesis in each round of cell division are complete within an hour. Typical somatic cells divide much more slowly, several hours to days, and even the fastest cancer cells divide much slower than occurs in a zygote during cleavage. Classification of eggs on the basis of amount of yolk. First, isolycythal eggs. These have a small amount of yolk that is equally distributed in the cytoplasm. Examples are mammals and sea urchins. Second, mesolycythal eggs. They have a moderate amount of yolk, and the yolk is present mainly in the vegetal hemisphere. Examples, amphibians. Third, telolycythal eggs have a large amount of yolk that fills the cytoplasm except for a small area near the animal pole. Examples are fishes, reptiles and birds. Fourth, centrolycythal eggs have a lot of yolk that is concentrated within the center of the cells. Examples are insects and other arthropods. Planes of cleavage. During cleavages, different cleavage furrows may divide egg from different angles. Some of the important cleavage planes are meridional plane. It runs from one pole to another, top to bottom, like the meridian on a globe. Second, equatorial plane encircles the zygote like the equator on the globe. Third, vertical plane. It runs from one pole to the another, but does not passes through the median axis of the egg. Fourth, horizontal plane. It is identical to the equatorial plane, but it courses through the cytoplasm on either side of equatorial plane. Types of cleavages. On the basis of amount and distribution of yolk, cleavage is of following types. Holoblastic cleavage. It occurs in isolycythal eggs. The entire egg is cleaved during each division. Second, meroblastic cleavage occurs when eggs have a lot of yolk. The egg does not divide completely at each division. These are of two types. First, discoidal cleavage. It is limited to a small disc of cytoplasm at the animal pole. All the yolk filled cytoplasm fail to cleave. Second, superficial cleavage. It is limited to a thin surface area of cytoplasm that covers the entire egg. The inside of the egg that is filled with yolk fails to cleave. These are the typical cleavage pattern of isolycythal, mesolycythal, telolycythal and centrolycythal eggs. Cleavage in sea urchin. In sea urchins, the first cleavage is meridional The second cleavage is also meridional. The third cleavage is equatorial. This creates an animal and vegetal half. The fourth cleavage is unique. Equal cytokinesis occur in the 4 blastomeres of the animal pole, giving rise to 8 mesomere, all the same size. Unequal cytokinesis occur in the vegetal pole. These causes 4 large macromere and 4 small macromere. The fifth cleavage is meridional. All mesomeres divide equally as do the macromeres. As the cleavage progresses, all blastomere adhere at the outer surface, but attachment is lost at the inner surface. The blastocele is a cavity formed due to the unequal adherence of the blastomere. Cleavage in amphibians. Amphibians eggs have a lot of yolk, however, they are still able to undergo holoblastic cleavage. The first cleavage is meridional, as is the second. The third cleavage is equatorial. The cleavage is displaced toward the animal pole due to the yolk. The result is 4 small animal blastomere and 4 large vegetal blastomere. Morula. At the 16 to 32 cell stage, the embryo is called a marula because it looks like a mulberry. Blastula. From the 128 cell stage onward, the amphibian embryo is a blastula. The outer surface of the amphibian blastula has cells connected by specialized cell junctions, for example, tight junction, gap junctions and desmosomes. The blastocele is displaced to the animal pole due to the presence of yolk in the vegetal pole. Cleavage in mammals. The mammalian egg is a little slow. It begins to cleave in the oviduct and continues until it implants in the wall of the uterus. One cleavage per 24 hours. Mammalian eggs have rotational cleavage, that is holoblastic. Asynchronous cleavage. Mammalian embryos are unusual in that they have asynchronous cleavage. Not all blastomeres divide at the same time. The first cleavage is meridional and the second cleavage is rotational. The two blastomere divide in different plane. One is equatorial and other is meridional. At first, the blastomeres of mammalian embryo have a loose arrangement and touch only at the basal surfaces. Mammalian embryos undergo compaction at the 8 cell stage. After compaction, blastomere adhere tightly, maximizing the area of contact. During compaction, each blastomere undergoes polarization. Tight junctions develop on the outer surface, allowing protein to specialize. Cells take up fluids from the uterine environment and secrete into the blastocele. Gap junctions form on the outer cells to aid in intracellular communication. After compaction, at the 8 and 16 cell stage, there are two types of blastomere. Outside blastomere, these are tightly joined and number about 9 to 14. They surround 2 to 7 inside blastomere that are loosely joined. Cavitation. The outside blastomere start to take up fluid from the uterus and pump it into the center, creating the blastocele. Blastocele develop at the cleavage, proceed to the 32 to 64 cell stage. The blastocyst is the hallmark of early embryonic development in mammal. Inner cell mass. This gives rise to the embryo and develops from the inside blastomere. Tophoblast. a structure consisting of outside blastomere. This contributes to forming the placenta. This is all about cleavage in animals. Thank you.